Hi, good morning everyone. Today I will continue share with you the property of the Laplace transform, the third property that is a shifting in S domain. If the Laplace transform of the xt, you will get xs, and then Laplace transform of the exponent s naught t xt, you will get xs minus s naught. The previously you learned that one is the shifting, okay, time shifting. But now this one is in S domain, it's not in time, okay. Now let's look at the example. Okay, an exponential function has the equation xt equal to 5 exponent negative 0.3t, where the t is in second. The function is delayed by 2 seconds and multiplied by a step function given by ut minus 2. Then find the equation for the delay exponential function. Okay, so first of all, xt equal to this one. Okay, xt is this one, and then the function delay by 2 seconds. So you need to write down the equation. So yt equal to the xt, right? Xt is 5 exponent negative 2t 0.3t, and then delay, the function is delayed by 2, so ut minus 2. This one also initially is 0.3t, but the function is delayed by 2, now change to t minus 2 and t minus 2. Okay, then find the Laplace transform of the delay exponential function. So you need to find the Laplace transform of the delay. So based on this question, based on this answer, you need to find the Laplace transform of the yt. You get ys. So for the shifting part, you get exponent negative 2s for the 2 here. Okay, for the s naught here is 2 xs. So xs is what? This part 0.3t, exponent negative 0.3t. You get 5. So 5 is a constant. You continue. You just copy down. Exponent negative 0.3t. You get s plus 0.3. Okay. So you get 5 exponent 0.2s over s plus 0.3. Okay. Now let's look at the graph. How's the graph looks like? Okay, if your xt is like this is your xt, 5 exponent 0.3t. Okay, this is the graph of the 5 exponent negative 0.3t. And then your xt is multiplied with the ut minus 2. Means that ut minus 2, when you multiply with ut minus 2, you just take the graph from t equal to 2. Okay, you just take the graph starting from t equal to 2. Before that, you chop off. So that's why you only get from 2 to infinity. What if your t also minus 2? Xt minus 2, ut minus 2 means that this graph, the everything shift. But if this xt ut minus 2, it's not shifting, it's just chop off at t equal to 2. But if you have xt minus 2, ut minus 2, you shift everything. You shift the whole graph of xt to the right. Okay, to the right. That's why you bring everything to the right. You see that the 0 here is at 5, right? So 0, you shift 2 unit to the right. Okay. Property number 4 is time scaling. Okay, so time scaling, this is referred to the scaling AT here. So xAT is equal to 1 over modulus A, x s over A. Okay, so this is the formula. It's quite similar to the Fourier transform. Okay, so this is the formula for the time scaling. And next property is the conjugate. Okay, conjugate is, okay, you have the conjugate here, the star here. So x conjugate t. So Laplace transform of the x conjugate t, you get x conjugate s conjugate. So in conclusion, you are just xs is equal to x conjugate s conjugate. The property number 6 is the convolution. So, okay, convolution. What is mean by convolution? You still remember? Or previous chapter also talk about the convolution. Okay, you convolute in the time domain, but you multiply in the x domain. Okay, let's say if you have x1 and x2 in time domain. So x1 convolute with the x2. Okay, x1 convolute with the x2, but in time domain is x1s, x2s. Okay. Let's look at the example of the convolution. Perform the convolution of the x1t and x2t using convolution theorems of the Laplace transform. Okay, x1t is a ut plus 5 and x2t is u and delta t minus t minus 7. So x1t you change to x1s. So unit step t plus 5. Okay, so Laplace transform of t plus 5 equal to what? Okay, so we can do it one by one. Like, okay, for this shifting part, there is an exponent 5s, and then Laplace transform on ut, so it's equivalent to exponent 5s, okay, divided by s. For the x2t, you change to x2s. So Laplace transform on delta t minus 7. Okay, t minus 7, the shifting is exponent minus 7s. For the t minus 7, you get exponent minus 7s, so shifting. For Laplace transform delta t, you get 1. So you get the exponent negative 7s. So convolution in time domain, so x1 is convolute with the x2, which is equivalent to the x1s multiplied with the x2s. So just now, x1 you get the exponent 5s over s, and x2 you get exponent negative 7s. So you just multiply. Okay, and then you simplify it, you get exponent 5s minus 7s. That one you get exponent negative 2s over s. And then this is the convolution x1 and x2. So in S domain, so if you want to get the result as a result of the x1 and x2, you can inverse Laplace transform of the x1s and x2s. Okay, so inverse Laplace transform of the exponent negative 2s. Okay, as you know, this is you can split into exponent negative 2s multiplied with 1 over s. So 1 over s is the ut. Okay, exponent negative 2s is a shifting. Shift how many? Shift t minus 2. So change to t equal to t minus 2. So you have unit step t minus 2. Alright. Now, let's look at another example. Perform the convolution of the x1t and x2t using the convolution theorems of the Laplace transform and sketch the resultant waveform where the x1t equal to ut minus ut minus 1 plus x2t equal to ut minus ut minus 2. So x1t, you change it to the x1s. Okay, how to change? So you see the Laplace transform of the x1t equal to Laplace transform of ut minus Laplace transform of ut minus 1. So Laplace transform of ut, you get 1 over s. Laplace transform of ut minus 1, so it's a shifting. So shift how many? Exponent, shift 1, so you get exponent negative s. Ut is 1 over s. And then for the s2s, also same, you get it from the x2t. So x2t is Laplace transform of the ut minus ut minus 2. So Laplace transform ut, you get 1 over s. Laplace transform ut minus 2 is a shifting again. Shift how many? Shift 2. So exponent negative 2s. And then Laplace transform ut, you get 1 over s. So you divide by s. So the convolution theorems, again, x1 and x2 multiply. So x1s multiply with x2s. Okay, these two multiply. So you multiply in this one, you get s, this one multiply with this one, you get 1 over s squared. Okay, here. And then this one multiply with, again with this one, you get exponent negative 2s divided by s squared. And then this one multiply, so minus with the exponent minus s divided by s squared. And then this one multiply with this one, so plus exponent. So this is minus s, this is minus 2s, so you get minus 3s divided by s squared. Okay, so this is the result of the x1 multiplied with x2. So if you want to get the in time domain, you need to inverse Laplace transform of this result. So inverse Laplace transform of the 1 over s, you get what? DUT. So this one you can check it from the table, Laplace transform table. Okay, Laplace transform of DUT, you get 1 over s squared. Laplace transform of DUT, u t minus t naught is exponent negative s t naught or divided by s squared. Okay, now let's look at another properties. There is a differentiation in time domain. Differentiate the xt, you will get x sxs. So using the differentiation property, show that the Laplace transform of delta t equal to 1. So we know that the differentiation of ut, you will get delta t. Okay? Laplace transform of the ut, you get 1 over s. So Laplace transform of the dut dt, so it's equal to s x-axis. This is from the formula. And xs is what? S is from the formula. Xs is referred to the delta t, right? And ut, right? Because differentiation of ut. So Laplace transform of ut, you get 1 over s. So you multiply here 1 over s, and you cancel out, you get 1. Okay. And then the next one is the differentiation in S domain. Okay. What is differentiation in S domain? Okay, minus dxt, you will get Laplace transform of minus dxt, you will get dxs over ds. Okay, why you say like that? You find the Laplace transform of xt equal to te negative a dut. So Laplace transform of the exponent negative a dut, you get 1 over s plus a. 1 over s plus a. So using differentiation in S domain, t exponent negative a dut. T exponent negative a dut, you get negative. Okay, differentiate in S domain. So t exponent negative a dut. So you assume that xt is this one. Okay, so Laplace transform on this one in S domain, you will get d negative d over ds. In the bracket is 1 over s plus a, equivalent to 1 over s plus a squared. Okay, and repeat the differentiation again. So you repeat this one, you differentiate again this one, you'll get t squared divided by 2, and then exponent negative a dut. Then this one again, you differentiate, you get 1 over s plus a power of 3. So generally, this is the formula. Instead of I write it in first order or second order, this is your general one. P power of n minus 1 divided by n minus 1 factorized. And then exponent negative a dut, you get 1 over s plus a power of n. Okay, let's look at another example. Consider the Laplace transform of xs equal to this one. Okay, find the xt. So this one you need to solve using the inverse Laplace transform. Okay. Alright, so this one, can you guess how to solve it? Yes, using partial fraction expansion, 2s squared plus 5s plus 5. So this one you can using partial fraction, so you split into. So here denominator have 3, so s plus 1, s plus 1 squared, and then s plus 2. So for the ABC. Okay, so you solve the ABC. You solve the ABC here. You get b equal to 2, c equal to 3, and then a equal to minus 1. So you substitute in, you get this one. And then from xs to xt using Laplace transform pair table, you change it, okay? You change it to the xt. And then after that, you have the ROC. You need to plot the ROC. S equal to minus 1, And then this is also minus 1, this is minus 2. So you plug minus 1 and minus 2. As you know, the ROC should not include the j omega axis. So you should the ROC should include the j omega axis and should not include the pole value. So that's why you starting from the -1 to the right hand side. Okay, class, do you understand? Okay, class. The last one, the last slide of the this lecture is the table of properties. So this is the summary of the properties. So you can view at your slide. Okay, that's all for today for the Laplace transform properties. And thank you for watching, class. Thanks.